Today we're looking at angles of triangles. We have two theorems we're going to examine. The first one is the triangle angle sum theorem. And the words here actually are a link to a video that's kind of a cool display of this theorem. It's a proof, but it's not a formal proof. It's more of a tactile proof. So anyhow, I figured I'd include that for you. We'd do it live in class if we got to be together, but we don't. So here we go. The sum of the measure of the angles of a triangle is 180 degrees. That's what this theorem states. So in this triangle over here, we would say the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Now we'll do a couple of examples there. Our job on this first one is to find the measure of angle T, which would look like this, of course, find the measure of angle T. So we have this triangle here. They tell me that angle R is 25 degrees and angle S is 35 degrees, and we're looking for angle T. So I'm going to use the triangle angle sum theorem. And I'm going to start by writing it out. So I'd say the measure of angle R plus the measure of angle S plus the measure of angle T would equal 180 degrees. Then I'll go back and fill in everything that I know. So I have a value for the measure of angle R from my picture. That's 25 degrees. And the measure of angle S, I also know that's 35 degrees. And then the rest of it, I don't have anything to fill in there. I don't know measure of angle T. That's what I'm looking for. So I'm just recopying the rest of the equation there. Now I'll do some combining like terms. So that's using the substitution property. 25 plus 35 is 60. So this would be 60 degrees. And then just copy the rest of the equation. That's supposed to be a plus sign. Came out kind of messy. All right, and then finally to solve for the measure of angle T, I would use the subtraction property of equality. So I'm going to subtract 60 degrees from both sides of the equation. So 180 minus 60 would be 120. So the measure of angle T here would be 120 degrees. Okay, so there are a couple of guided practice problems here. So this would be the place to pause the video and then try both of these problems and then come back and see how you did. Okay, so for these two problems, the first one, the measure of angle 1, which was the one we were looking for, was 28 degrees. And on the second one, the measure of angle 1 was 120 degrees. Now, I did want to talk a little bit about these two because there are some special things here. The angle on the left there would be a right triangle. And with a right triangle, since one of the angles is 90 degrees and the sum of all three of the angles is 180, well, you could actually probably do this problem a little bit simpler because that would mean that the sum of the two angles that are not the right angle would have to be 90. So this angle and this angle would have to be complementary. So you could do a little bit simpler problem for this one. Oh, that was really, really bad. Plus 62 degrees equals 90. And then solve that one, you would still get 28 degrees. That's actually a corollary, which is a kind of a little theorem that's related to another one. It's a consequence of another theorem. Okay, for the other one over here, we did get 120 for measure of angle 1. And the special thing on this one was that it showed that the two base angles over here were congruent. It showed that using an arc, and we talked about that a little bit before. So you would have to remember that in order to make that work. Okay, for our next example, our picture is a little bit more interesting here. This time we have two triangles. We have triangle ABC and triangle CDE. And we're supposed to find the measures of the three angles, the three numbered angles there. So we're going to have to come up with a plan here. So first thing I notice is in triangle ABC, I know 2 of the 3 angles, and I see that this one is 90 degrees, which means that this is a right triangle. So I can use that fact that we just discovered there. That means that these other 2 angles within this triangle have to be complementary. So I'm going to start off to the side there. Measure of angle 1 plus 58 degrees is equal to 90 degrees. And then use the subtraction property of equality to subtract 58 from both sides. So that would give me 32 degrees for measure of angle 1. All right, so I've got one of my answers here. I'm going to go ahead and box that so I don't lose it. And then I go back and look at my picture. And on the picture, in the other triangle there, triangle CDE, I only know one of the angles, and it is obtuse, so I know for sure that this one is not a right triangle. But what I can get, because angle 2 is a vertical angle with angle 1, that means angle 2 and angle 1 are congruent by definition of vertical angles. So I can say measure of angle 2 is also 32 degrees. And I'll go ahead and box that one as well. Okay, so now if I know that this angle is 32 degrees, and I know that this one is 108 degrees, I can use that to find the measure of angle 3. So I'm going to go ahead and use the triangle angle sum theorem for this one. So I'm going to start with measure of angle 3. And then I'm going to go ahead and do the substitutions when I do this one. So I'll do measure of angle 2, which is 32 degrees. And the measure of angle E, which is 108 degrees. And that has to equal 180 degrees. Then I'll put together the 2 constants here. This is using the substitution property because I'm substituting this sum of values with what it's equivalent to. So 108 plus 32 would be 140. And then to solve for the measure of angle 3, I would use the subtraction property of equality. So I'm subtracting 140 from both sides. And I would get that the measure of angle 3 is 40 degrees. And so now I've solved for all of the measured angles. Okay, now before we move on to the next theorem there's an extension question on this one. It says, what is the measure of angle BCD? So looking at the picture there, let's go back and look. BCD would be this angle right here. So take a moment and think about that one. Could you figure out the measure of that angle? I see 2 ways to look at it. I see that it forms a linear pair with either angle 1 or with angle 2. And we know that linear pairs are supplementary, so they add to 180 degrees. So if I wanted the measure of angle BCD, I'm going to go ahead and write that down. Measure of angle BCD plus, I'm just going to pick one of those. Angle 1 or angle 2 does not matter. They're congruent. So I could say a measure of angle 1 is equal to 180. And that's because they're a linear pair. Then I could substitute in the 32 degrees for measure of angle 1. And that would give me a new equation to work with there. And then to solve for measure of angle BCD, which is what we were looking for, I would just have to subtract 32 degrees from both sides. So I would get the measure of angle BCD is equal to, let's see, that would be an 8. 148, there we go, 148 degrees. Okay, so because of the way that the picture's set up, that makes this angle that they were asking me about a linear pair with some of the angles inside the triangle. This is also what we would call an exterior angle, which leads us into our next theorem. We do have a couple of guided practice questions here, so you're going to pause the video at this point and try these two problems. You're going to find the measures of all of the numbered angles, and then come back and see how you did. All right, so on these two, for guided practice problem number 3, the measure of angle 1 was 56 degrees, and that was using the triangle angle sum theorem. Measure of angle 2 is also 56 degrees because it is a vertical angle with angle 1. And the measure of angle 3, using the triangle angle sum theorem again, was 74 degrees. On guided practice problem number 4, we have two right triangles that we're working with here. And so I could use the corollary, which says that the two angles that are not the right angle are complementary. So I just put measure of angle 1 plus 60 is equal to 90 there. I got the measure of angle 1 was 30. And I used the same corollary with the other angle, angle 2. And I got measure of angle 2 is 60. Okay, so our second theorem is the exterior angle theorem. So let's talk about exterior angles first. At each vertex of a triangle, the angle formed by one side of the triangle and an extension of the other side is called an exterior angle. So I've got a picture down here to look at, and the angle that is labeled angle 1 on here would be the exterior angle. So I've got my triangle here. One side was extended, so the angle that's formed between the extended side and the side of the triangle there. That's your exterior angle. So this theorem, again, there's a proof of this one as well that's kind of cool to look at, and it's linked here. So if you wanted to watch that later, you can. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So that would be the two angles that are not next to that exterior angle, not adjacent to it. Okay, so in symbols, this one goes, measure of angle 1 is equal to measure of angle A plus measure of angle B. So this angle here, this exterior angle, is equal to the sum of these two angles that are not adjacent to it. All right, so we have an example or two. Oops, this is not what I wanted to use. Let me use this one. All right, so we're looking for the measure of angle 1, which is this angle here. It is an exterior angle on this triangle. So according to this theorem, I would say the measure of angle 1 is equal to the measure of angle S plus the measure of angle R, the two angles that are not adjacent. I call those remote angles. Then I'll fill in all the information that I have from my picture. Measure of angle 1 is what I'm looking for, so I'm going to leave that just as measure of angle 1. Measure of angle S is 80 degrees. And the measure of angle R is 60 degrees. And then I can sum those. So 80 plus 60 is 140 degrees. So not bad. Let's do another example here. So this time, we are looking for one of the remote angles. So they tell me on this one that, we're looking for X. Okay, so X is going to be whatever number here goes with the degree symbol here for angle S. And they tell me that an exterior angle over here is 78 degrees. So I don't have a number to describe that one, so I have to describe it using 3 letters. So I can call this one PQS. So I'm going to say the measure of angle PQS, the exterior angle, would equal the sum of the measures of the remote angles. So that would be the measure of angle S plus the measure of angle R. And then I can fill in everything that I know. So angle PQS, measure of angle PQS is 78 degrees. The measure of angle S is X degrees from my diagram. And the measure of angle R is 55 degrees. So all I have to do is solve this one for X, or for X degrees, I should say. So I'm going to use the subtraction property of equality. I'm just subtracting 55 degrees from both sides. So 78 minus 55 would be 23 degrees. And now the question was to find the value of X. So what I've got here is X degrees. X degrees is 23 degrees. So the answer that I would give here is that X is 23. All right, 2 more guided practice problems. So at this point, you're going to pause the video, try these 2 problems, and then come back and see how you did. All right, so these 2 were both pretty straightforward. The one on the left, we can use the exterior angle theorem to find the measure of angle 1. The measure of angle 1 is just the sum of the 2 in there, so that was 115 degrees. On the second one, we would use the exterior angle theorem to find our measure of angle 1, because it is an exterior angle. So that's just the sum of the 2 remote angles. And then for the interior angle, we would use the triangle angle sum theorem. So the sum of the 3 angles is 180 degrees. And then solve, and you would get the measure of angle 2 is 120 degrees.